In this video, we're going to talk about solving quadratics by factoring. So the first step is to set the equation equal to 0. So your equation should be in the form ax squared plus bx plus c equals 0. The x squared, or the quadratic term, should be positive, so you want to make sure you have a positive first term. Step 2 is to factor the left side of the equation, so we're going to factor this side here. Step 3 is to set each factor equal to 0, and the 0 property of multiplication allows us to do this. Step 4 is to solve each of the resulting equations and to report your answer or answers. Alright, so example number 1. I have n squared plus 42 equals 13n, and I need to put it into the standard form for the quadratic equation, so this form right here. So in order to do that, I'm going to need to subtract 13n from both sides. So I would end up with n squared minus 13n plus 42 is equal to 0. Step 2, I want to factor this trinomial here. So I'm looking for factors of 42 that add up to be negative 13. So 42 is equal to 6 times 7. And since this is a negative 13, my two factors are going to be negative 6 and negative 7. So that gives us n minus 6 times n minus 7 is equal to 0. And then I'm going to set each of those equal to 0. So n minus 6 equals 0, and n minus 7 equals 0. So if I add 6 to both sides of this, I'm going to end up with n is equal to 6. And if I add 7 to both sides of this equation, I'm going to have n equals 7. So my two solutions are 6 and 7. Right, example number 2. Now this one would be a candidate that you could use square roots in order to solve it. But I'm going to show you how to solve this using factoring, and you'll see that you'll get the same answers. Alright, so what I want to do is I want to subtract 25 from both sides because I want to get this in the correct format. So it's going to give me v squared minus 25 equals 0. I recognize this as a difference of squares, so my two factors are going to be the square root of the first term, so square root of v squared is v, plus the square root of the second term, so square root of 25 is 5, and then the square root of the first term minus the square root of the second, so v minus 5. Set each of those factors equal to 0, so v plus 5 equals 0, and v minus 5 equals 0. This factor here gives me the solution v equals negative 5, and this factor here gives me the solution v equals positive 5. So my solution set would be plus and minus 5. Example 3, we want to go ahead and put this in the right format. So I'm going to need to add 30 and add 41v. So it's going to give me 7v squared plus 41v plus 30 is equal to 0. Double check. No GCF. 7 is not a GCF. Can't factor 7 out of 41 or out of 50. So we know we need to go ahead and try to factor this. Okay. So in order to do that, I need factors of 30 times 7 that add up to be 41. So first, that gives me 30 times 7, which is 210. So I want factors of 210 that add up to be 41. So factors of 210. Well, this ends in a 0, so I know 10 is a factor. That gives me 21 and 10. Not quite the ones I was looking for. They don't add up to be 41. All right, so let's try 5. I know 5 is a factor. That's going to give me 5 and 42. That doesn't work. 7 is a factor of 42, so I know 210 is divisible by 7. So that gives me 30 and 7. That's not going to work. 30 is divisible by 6, so that's also going to be a factor of 210. So 210 divided by 6 gives me 35 and 6. So there's a pair of factors. All right, so I'm going to go ahead and put this into my grid here. Let's go here. So if I put 7v squared and 30, and I know I need a 35v, and I need a 6v. Only factors of 7 are going to be 7v and v. Okay, so this is going to have to be 7v plus 6, and to get a 35v here, I'm going to need a 5 here, so plus 5. So my two factors are going to be 7v plus 6 times v plus 5 equal to 0. So then I'm going to set each of those factors equal to 0. So I have 7v plus 6 equals 0, and v plus 5 equals 0. From this bit here, I'm going to have the solution v equals negative 5. And from here, I'm going to have v is equal to negative 6/7. So we subtract 6 and then divide by 7. So my solution set for this problem is negative 5 and negative 6/7. Example number 4. I'm going to go ahead and factor this, check for a GCF, and in fact I do have a GCF. It's an n. So I'm going to factor out an n, and that leaves me with n plus 6, and that's all equal to 0. Set each factor equal to 0, so n equals 0, and n plus 6 equals 0. This one's already solved, so I don't have to do anything with that. Here, if I subtract 6 from both sides, I end up with n equals negative 6. So my solution set is 0 and negative 6. Last example, example number 5. Put this in the right format. Subtract 10b from both sides. So I have b squared minus 10b plus 25 equals 0. So I need factors of 25 that add up to be negative 10. Those are going to be negative 5. Or I can recognize that this is a perfect square trinomial. This is a perfect square, and this is a perfect square. And 2 times b times 5 gives me 10b. So if I recognize that, I can factor this using my special case trick. B minus 5 squared is equal to 0. So that means b minus 5 equals 0, and b equals 5 is my only solution. This is what's called a repeated root. And so in this case, there will only be one solution to the quadratic if you have a perfect square trinomial.